guys, welcome back. This is me Abhishek and welcome to my YouTube channel. And today in this video we're gonna cover classification in machine learning. So this video, what we're gonna discuss in this video, we will cover all the basic to advanced all techniques by using we do classification, right? So in this particular video what we're gonna cover, we will train our classification model. We will not just train one model, we will train various model, and we will analyze all those scores, and we will cover F1 score. We will try to cover AUC ROC score, and we will cover everything, right? AUC ROC score and F1 score, balanced score, and we will cover everything. And stick to this video, everything will be crystal clear. Okay, so we will understand all those metrics which we use for classification, like it could be micro, it could be macro, and weighted F1 and all these things. So and then third, you will be able to understand ROC AUC score and precision recall trade-off and TPR FPR trade-off. If you don't know TPR and FPR, I will discuss all those things as well. And we will discuss confusion matrix and hyperparameter tuning by using Bayesian optimization. So in this video we will tune our model as well by using Bayesian optimized tool, and in this video I will be using optional, which is I would say the best tool. And then we will analyze the score, and analyze the score means we will try to find out our answer. We will try to find out our question and predict the answer by using that score, and by getting that score what we understand and all those things. And then at last we will adjust our threshold for production model. Like if we just want to publish our model somewhere on a Flask, then we will do little bit of adjusting threshold, right? And I will tell you when and where and in which case we adjust our threshold, right? So all these things we're gonna discuss in this video. So here, let's start. I'm using heart disease CSV. If you don't know heart disease CSV, you just simply go and Kaggle. I will tell you one more thing. uh, you can work along with me by using the same notebook. If you really care of your time, you really don't need want to create new notebook and all those things, you can simply copy this heart disease CSV. You can simply copy this notebook. You can simply copy this notebook and work along with me. I'm using heart disease UCI dataset. uh, Here you can either make notebook from here from scratch. Your notebook will be totally empty, you have to write each and every line of code. And other thing you can do, you can just simply copy and edit notebook. You can see, you can make a copy of my notebook and you will work on that notebook. So you can do either way. I will drop my notebook link in description. You can check out or you can work along with me. So this is so so let's start. So I have told you what all those things we're gonna do in this notebook, and trust me, I will keep everything concise. I will keep everything so simple to understand. Okay, and wherever you will need some extra knowledge, I will prefer you links where you can read all those things. Okay, so let's start. So what simply I have done, you just run this cell to confirm. You just run this cell to confirm that whether your data set has been loaded or not. So you just run. Okay, I'm running this cell, and mm, okay, just run this. Okay, I think it's has run, and now I'm importing my data set. Oh, I think there is a problem. Let me restart this notebook. Just wait, guys. I will start this notebook again. Let me pass. Here we go. We just run this cell to confirm that what are those files in our loaded data frame. So you can see that we have this file on our loaded data set, which you can see right here. I have this file. So this just shows you path and import PD and NP, right? So after running this, I will just make a full screen. After running this cell, what I have done, I have used a read CSV PD. Read CSV is really very basic, and I don't think that I have to explain this again. And then I'm just looking some head column, just five columns, uh, 5 rows of this data frame, and you can see this is my data frame, and here you can see here the target column is my output, and all these are my input features, right? So since this data frame has not very and this data frame has no not very much columns, and that's why we are not using any kind of feature engineering or feature selection. We can use feature engineering, but right now I'm not using feature selection. Let me tell you, when we have so many columns and some of them are useful, some of them are not useful, only then we use feature selection, because so many features will make our model very complex and confused, and we always want a generalized model, and that's why we do feature selection. So I whenever you have just 5 to 10 features, you really don't 5 to 10 or 15 features, you really don't need to worry for feature selection. Okay, so this is point number one. Whenever we will have so many columns, only then we will do feature selection, because just 2 or 3 extra columns will not make our model so complicated, and that's why we are not using any type of feature selection yet. And now I am just running df.info just to see if I have any kind of null data, null rows. So I and these all numbers are matching, so I can say that I have no any kind of null data. And d type, everything must be int or float, so everything is here int or float. If there is something called str, there is something called string, you have to change into you have to change any kind of string. If you have any kind of string, then you have to change that. You can either make a dummy variable, or you can make by using label encoder, but every features must be int or float. Okay, now start. I'm just making a dictionary of having 0 as key and value as not diseased and disease, because our target is 0 and 1. 0 means you have heart disease, and 1 is you are not having any kind of heart disease. So just running this dictionary. Here what I am doing, I am um, trying to make a plot so that we can see how many target are we having, and how many number of target we are having with different class. And that's why here I have imported matplotlib as plt, and then I am importing cborn as sns, and then I'm creating a figure, and I'm creating axis and plt.subplot. Whenever you want to create so many plots at the same canvas, then we use the subplots. Okay, so I'm using 1, and figure size is 7 and 7, and then I'm using axis equal to sns count plot. Count plot does what count plot does, count plot count every class in that column, and it plot the graph. So so here I have df target and map. What I am doing, I can even not use map, but I'm using map so that we can, wherever 0 comes, it will show you not diseased, and wherever 1 will come, it will show diseased. And I'm giving this axis, and then I'm setting vertex. So let's run this. So as you can see, I'm getting diseased 165, and not diseased somewhere around 140. Okay, one more important thing which I'm gonna do, I will change the theme actually, like if you can't understand. Okay, so diseased 165 and not diseased is 135. Oh, okay, so I think it's clear yet. And now let's move on. And here I'm creating one more graph. figure axis PLT subplots, and this is all part of plotting. If you don't know plotting, you have no idea how to do all this plotting, you can kindly refer any medium documentation, or you can simply watch my videos. I can drop you link on I button. You can go and check out how we do plotting. Okay, so I'm using here target equal to, since my target is df dot target, and I'm still I'm again mapping by classes. What it does, it just simply converts 0 to not diseased and 1 to diseased, right? Gender is equal to, I'm plotting gender map, again I'm plotting this, and then axis counter plot and all these things. You can just see this, and let's run this. Okay, as you can see here, in disease, whoever have any kind of heart problem, um, male have most heart problem than female, and not diseased, again male have male is again leading here. So it shows that in the whole data set, in the whole data frame, we are having most number of males, and that's why this is showing me. So we can't say that female are more prone to our disease and male are more prone to our disease. So we cannot say that at this stage. So again I'm making a color bar palette. So what palette does, I'm telling you, it is just for plotting. You can't even just skip this part, but I'm telling you what plot palette does. It create a palette. Suppose if you want blue color, if you want your graph, uh, if you want to look your graph in blue color, you just simply plot select palette at 0 1 2 and this and all these. So you just select the color, and that's all. So here I'm creating a loop, and what I'm trying to do here, I'm trying to plot every column one by one over iteration. So what I have done, I have selected all the features except target, and that's why I have did this. And then I'm creating figure and axis again by using subplots, and then figure size I have given, and fit tight layout, I'm doing tight layout, and I'm giving padding equal to 5. What padding does, padding separate the charts. They padding keep a gap between charts so that they can't overlap. And then I'm just doing this, and I'm using pw as one point. You can you can increase this. If you will increase the thickness will be very high, and that's why I'm keeping is -1. And color palette, I want blue color, that's why I'm selecting 0 as blue. Okay. Here it will select blue. So run this. Sorry, let it run. Okay, so here you will see age, maximum age we are having is more 55 to here, and all these plots. And then we can say sex means male have more, and then CP, all these plotting. This is all about plotting, and they really don't need, since we are not using any feature selection. That's why these plotting are not really very important for us. So the real coding start from here. So x will be our input variable, that's why I have selected dfi lock all rows, and df dot columns, all columns which not matching to target. This is how we read this, and just run this. And then I'm using SQL learn model selection, and these thing test size I'm keeping as 0.3. I'm using stratify is equal to df dot target. What stratify does, it keep the same, it keeps some fixed ratio, it what stratify does, it keeps some a way, it almost keep a ratio between your train data and test data based on target. So this is what actually does. If you don't need train, if you don't need stratify, it can be that every positive class will come in your x data randomly, since train test split works randomly. And what it will do, if we are not using stratify, it might do that every class every positive class will come in x train, and every class 0 will go on y train. And that's why To get rid of those situation, we are using stratify equal to df dot target. So it will separately divide class 0 and class 1 in x train, and class 0 and class 1 in y train as well, in a fixed ratio. Now run this, and now I'm y train counts value, I'm doing counts value. You can see in one I am getting 115 data of class 1 and 97 data of class 0. If we are not using stratify, what it does, let's have a look. Again it's showing up because I have fixed a random state. Let me change this random state. So it may change, it may change, again I'm telling you, and that's why I'm using stratify. For bigger data we always use. So now what are we doing? We have imported f1 score and max scorer. If you don't know about metrics and scoring function, then just stick with this video. I will give you a very short explanation, and I will give you a very short description of all those metric functions, right? So first what I have done here, I have imported f1 score. I have imported a max scorer. What, why and where we use max scorer? Suppose in metrics, suppose our objective is we have to reduce uh, log error, log of root mean square errors, and in your matrix you have only root mean square error, and you have to calculate log root mean square error. So whenever you can create your own custom scorer, what you do, you import max scorer, and here you pass a function, which take y true and y predicted and returns a score. And then we specify greater is better. Suppose if you this custom function returns error, then you will say greater is better, no it will be false. And if it returns a score or accuracy, then you will say greater is better, you will say yes. So in this way. And here from sklearn model selection I have used stratify k-fold, and then I'm using cross validation, and then cv equal to stratify, and then I have created a accuracy score. Here I will pass model and it will gives me scores, and here I am using score mean. I'm using scoring balanced accuracy. You can either use I can use f1 scorer, which we have created, f1 scorer. We can use this, or we can simply use balance accuracy, right? What balance accuracy will do, let me tell you. Suppose you have multi-class classification, or you have binary classification, so you will have two classes, 0 and suppose 1, and the accuracy of for 0 will be calculated separately, and for 1 it will be calculated separately. So whenever we do hyperparameter tune, we always try to find balance accuracy must be maximum. So what we do, we calculate separate individual accuracy for 0 and 1, and then balance means their average. So we want our class 0 will have more accuracy, maximum accuracy, and class 1 will have maximum accuracy as possible, and that's why we are using balance accuracy. Suppose for class 0 we will have accuracy a0, and for class 1 it suppose it is a1, so the balance accuracy will be their average. Okay, so our model will keep a balance, so that the accuracy for class 0 and class 1 will be balanced. Now just running it. Suppose if you don't know how many scoring function are we having in sklearn matrix, then what do you have to do is just copy these codes, sklearn import matrix and import scorer classes, and then scorers is a dictionary. Again, scorer is dictionary, matrix is a class, and so that's why we are using keys. So it is giving me all the dictionary keys. So this is all our matrix available in our sklearn. What you can do, one more thing, that everything you see here is a keys, and what we can do, scorers, dot values, and it will gives us every scoring function has been made by using max scorer and pass a function. You can see here these all are the hidden functions of every matrix which we are trying to create, which we were trying to create by using max scorer. So for now, just don't focus on this, just focus on keys. So we have F1 macro for classification. We use F1 macro, and F1 weighted. We use recall. We use F1 score. We use AUC ROC, and we use balance accuracy. When we use F1 macro and F1 weighted, whenever we will have a very imbalanced kind of data set where the number of class there where number of samples of class 0 and class 1 will have a very different, um, suppose class 0 has 100 data and class 1 will have 2 3 data, and in that case we will say this is imbalanced data, and in that case we use macro F1 samples, all these things. And so if you want to know more about it, you can simply prefer a on Google. What you have to write, you have to write just classification metrics. Okay, and I can tell you all everything about it, but it will let our video a very long time. So that's why video will get very long, and that's why I'm not explaining all these things. So then so here guys, what are we doing? Uh, we are we are comparing all the models, right? So we are comparing all the models. So I have created a dictionary, and then I have imported all those libraries for these models, and then I have created a list, and then I have created I really don't need this list, so I removed this. Then I created a dictionary, and then I'm importing these dictionary by model that item. What it returns, it returns keys and then values, and then model pipeline. I have created a pipeline. In pipeline I'm using a standard scaler. What it does, it scale our data. It is we have two type of scaler. We have an standard scaler, and then we have min max scaler and normalization. We have many kind of thing, but so what standard scaler does, it scale our data to mean as 0 and standard deviation. That's one. So and then we are scaling our data and then passing to our model, so that our model, why we are using make pipeline, we could have done standards, we could have scaled all data and then passed to the model, but in that way our data might have leaked, and that's why we are using standard scaler, right? And then we are printing by using what you call it as, you say it as string. So f is f string, and then we have this string comprehension, something like that, and then in curly braces we pass our variable, and then I'm calling AUC score function. Actually I should name it as ACC score function. I have a uh, named it as ACC score, then I will change ACC score and then run it, and you will see our accuracy, balance accuracy, which is maximum for ext classifier, which is extra tree classifier, and that's why we will select this model for further improvement. So I have created a base model without any hyperparameter tuning to just show you how what classification report of how its score comes out. So here it was showing 84.15, but here it's showing 83.33. So don't worry, the extra tree classifier randomly changes, so that's why you have to fix a random state, and then your answer will be same for every time. Okay, now I'm fitting our data. it's just a base model. I'm creating right now a base model without using any kind of hyperparameter tuning. And then after fitting, I'm just predicting our X test. And then I have created a classification report. As you can see here, uh, recall for one is 92, and precision and recall. What recall shows you how many true zero is predicted by. No, recall means what amount of class value our model able to predict truly, means what kind of amount of that class our model are able to pick. Suppose in class 0 I have 15 0, then 15 0, if model is able to predict all 15 0, then I will say our recall is 1. And in this case, suppose in my 100 I have 0 class, and in 0 class I have 100 0, but our model is able to predict only 80 0 correctly. And in that situation our recall will be 80. And precision 89. What precision means? Precision means true predicted upon total predicted. Suppose for if we want to calculate the precision for 1, we will say uh, all those numbers in which our model says it's 1 and it was actually 1, means true positive upon total positive prediction. True positive upon total positive prediction. So this will be our precision. And then accuracy we can see here, and you will able to see here macro average, all these things, and weighted average. So macro average is thus just average of all those classes of this precision. This is just average of 89 and 85, and recall is just average all these things. So, and then I'm creating a confusion matrix. The best way to make a confusion matrix, you can just call confusion matrix and then give y test and y spread. There are so many ways to make confusion matrix. You can either use pd.crosstab, you can use plot confusion matrix, you can use confusion matrix. So I will show you all those methods in this video. And then for checking if our model is overfitted or not, we just make accuracy. We are just trying to find accuracy of train and test data. So here you will see our test data giving accuracy of 86, but our train data is somehow giving accuracy of 1, because I will say that it's simply overfit, because training is 1 but testing is 86, and I will say our model is overfitted. That's why. So now in this case, let's try to improve more our model by using hyperparameter tuning. We are not using grid search CV, we are not using random search, uh, but we are using Bayesian optimized hyperparameter tuning by using Optuna. So if you are using Kaggle notebook, you are using Google Colab, you don't need to worry, just do pip install Optuna, or just simply but in every cloud notebook Optuna has already installed the, so that's why you have to just import Optuna. If it throw any error, what you will do, you will do pip install Optuna, right? Optuna. So you will do this. Otherwise, just import Optuna, and from Optuna import trial and visualization, TP sampler and Optuna.sampler. What TP sampler is? TP means tree Parjan estimator sampler. This is Bayesian optimized algorithm actually. Just run this, and then I will run these parameters. So what are these parameters? These are parameters which we should focus on while tuning extra tree classifier or extra tree regressor. The first will be an estimator as colon trial dot suggest int. So we are calling trial dot suggest int. So an estimator will be int, and categorical criterion always used to be a categorical, so I'm using Gini and entropy. Maximum depth I'm giving here, and minimum sample split, it must be integer, that's why suggest dot int, and then 2 to 10. Minimum sample leaf allowed value is 1 to 10, and maximum feature is categorical, again auto, square root, and log 2. And then again we are making a model, make pipeline, standard scalar, extra tree, and here I'm using keyword argument double asterisk to just since this will be a dictionary, so to open this dictionary we are using two asterisk, and then we are passing our random state and 42, and we are calling the same function we made for our calculation of score, which was ACC score, and that's why I'm calling and returning. Since this is objective function, so we have to return this. So for tuning we have to just import this one, and the second step we have to make a objective function, and the third step is we have to call study. So for calling study when equal to up to now create study direction, we want to maximize our accuracy, that's why we are mentioning here maximize. And sampler, I'm using tree parsion sampler, and trial equal to 200, objective we have to pass the same function here, and then progress bar equal to true. So here I will be able to see a progress bar which tells us how what time it will take to complete. And so I think it's gonna take us a little time. So and should I pause this video? Okay, I'm gonna pause this video to save your time. Meanwhile my laptop will be on charged. So our estimation, our searching has done. So our searching is done. So let me tell you why I'm using option. I'm not using random search CV. I'm not using grid search CV, because Optuna is currently the best tool for hyperparameter tuning. Let me tell you why. Because it gives you plotting. It is fast, and it is fast actually. And this is again very best tool, and it gives you so many visualization to figure out what kind of value you should take for um, different type of parameters, and that's why. So the best parameter comes an estimator is 108, criterion Gini, maximum depth 4, minimum sample split, and maximum feature as square root. So you will able to see all these are parameters, all these are history, how our Optuna has improved. Look at this really done a good job, and that's why I'm using Optuna. So for plotting visualization you can use Optuna.visualization history. And let me tell you one more thing. Whenever we tune, we always get confused that what range of model we should take for improving our model, what kind of range we should take for different hyperparameters. And this is basically very simple in Optuna. What you have to do, just plot a slice plot and give the study one, because we have given study as one. Here you will able to see here, and you will able to see here whenever our model selected Gini, then our score was maximum, and here maximum depth must be 4 because it's giving me a highest accuracy. And then auto, it must be auto or it must be square root, but you will be able to see that square root has more, 84.79, 84.7993, that's why it's selected square root. And then minimum sample split must be 6 or 5, so I would say both have the same, but it will select 6. Minimum sample split, you will be able to see that we are getting exact, and then we will select 4. An estimator, you will be able to see that an estimator is 94, 95, 116. This is the range of an estimator, and that's why our model is selecting an estimator from this. So and then I'm now creating the model tuned. So how do we pass the parameters selected by our optional? We don't need to we don't need to copy paste in our parameters. What you have to do, just get the study.best params, and this will be a dictionary. It will be a dictionary, and just wait. So guys, here we have just made a model again, By using two asterisk, what it will do, it will convert our dictionary into parameters, and then we have passed a random state at 42 because extracted classifier changes randomly, and that's why we fixed a random state. And then just run it and then calculate its score accuracy, ACC, and you will be able to see that it comes out 84.79. We read it as, and here you can see 84.79 was our best trial accuracy, and before hyperparameter tuning it was 83.33, and after tuning it comes out 84.79, means we have improved somewhere around 2%. And again guys, if dataset will be larger dataset, if we are working on larger dataset, our improvement will be further more. On small dataset our improvement will not be much more. And then model, now I'm fitting our model to our dataset, and then I'm predicting. Okay, now we are creating a classification report which will gives us every summary. Now you will be able to see that our recall is 80, means 80% of our class 0 has predicted by our model, and 94% of class 1 have predicted correctly by our model. You read recall as this, means 80% of class 0 has predicted by our model correctly, and 94% of uh, data our model correctly classified for class 1. And precision you will be able to see, and accuracy you will be able to see. Precision means how precise your prediction was. Suppose means how many correct prediction your model did upon total prediction for class 1. Okay, you read something like this. Now let's see overfit and underfit. So you will be able to see that our testing score is 87.91 and training score is 86.79, means your testing score is much higher than your training score, means your model is ideal for right now. It's not overfit, it's not underfit, it's best model. And testing score is more than training score here. Now for confusion matrix you have two methods. You can either print confusion matrix, or you can call plot confusion matrix from scalar matrix, and then you pass your tuned model, since we created a model by name model tuned. So we will pass our model when we will pass our test data. So now this will be look like this, and here you will get annotation and labels as true level and predicted level. Here you will be able to see that true level was 33 and predicted level was 33, means 33 data of class 0 has classified correctly, and 47 of data of class 1 correctly classified. And how many total sample was in class 0? It was 33 plus 8. And how many data was there in class 1? It was 40, it was 50. So out of 50, 47 of class 1 has class. Now, so I hope this is clear till now. So now a very important thing which we should understand, right? We have, suppose and I'm considering that you have a basic idea of recall, and you have a basic idea of recall, precision, and TPR, true positive rate, and false positive rate, FPR, and these idea comes from AUC ROC curve. And okay, so let's start from basic what I'm talking about. So our boss said us to make a model. What kind of model? To predict COVID cases. So I will create a model so that we can predict all COVID positive cases. So in this model we are not concerned if our model says someone positive if he is negative. So if someone is negative and our model said positive, then he will be in isolation. He will be isolation despite having a COVID negative. So that's not wrong. That's not a problem. If someone is negative, he is in isolation, that's not a problem. But if someone is positive and our model saying he is negative, then it's problem, because if our model says negative, he can't get in isolation. So what I want, uh, in this confusion matter, you are able to see that we had total 50 COVID cases, right? And out of 50, our model are able to predict only 47 COVID positive as positive, and the rest 3 COVID positive our model said as negative. So this is really very big problem. Why it is big? Because you said 3 COVID positive and negative, and they will boost infection. They will, like, they will boost everything. They go everywhere and they will spread virus everywhere. And that's why what I want to set, I want to create a model in such a way that 50 to our model are able, our model should be able to predict all 50 cases at COVID positive. And it's not our concern, we will not worry, we will not be able to worry if our model says someone, if he is negative and our model says he is positive, then it's not our worry, because if anyone is negative, he can't still get in isolation if our model says positive. So that's not the case, that's not the reason of being worried. Okay, so what I want to maximize our recall for class 1. We want to maximize our recall for class 1 means we want to predict whole data from class 1, whole data. So how will we do that? Okay, we have one graph from ROC AUC. This is basically ROC graph. ROC means receiver operator characteristic. Here we get recall, we say at as TPR. Okay, and here we get FPR, right? FP and R, and our graph goes something like this. No, sorry, our graph goes, I have to remove this. I have to remove this. Okay, our graph goes like this, something like this. Okay, when you observe this, as you increase your recall, FPR increases. What does it mean? If you want to recall, if you want to increase recall that our model should be able to predict all 50 cases, then your model will not be that much precise, because your FPR will be increasing. What FPR means? FPR means false positive rate. Means if you say it, no, it's positive and it's false. If our model says it's positive, means it's false, means our model predicting someone as positive and he actually was negative. So it can increase, but that's not our concern, because again I told you that if someone is negative and our model says positive, that's not the case, that's not the reason of worry. So that's why we are not focusing on FPR. We will try to minimize FPR as much as possible, but at the same time we will maximize our recall. So let's do this. I'm just right now I'm just creating our ROC graph. I'm using positive praba. What positive praba is, let me show you. What positive praba is. Positive predict praba, as we know that we have various method for prediction. We can predict praba, predict log praba, and predict simply gives you classes, predict praba gives you probabilities, right? Just run this, and suppose I also wanna print. So you will see that this is giving me all the probabilities of having 0 or having 1. So you can see this is for 0, this is for 1. For 1 you are able to see that I'm getting 0.71 in probability, so the first class will be 1. So right now I am focusing on class 1 because class 1 is COVID positive cases and we want to increase our recall as much as possible for class 1. So what I will do, I will select all rows and first column which is for uh, 1 class. This is for 0 and this is for 1. You can say as positive class, so you will be able to see that I'm getting all the probabilities for positive class. Now I'm calling ROC curve, which gives you FPR, TPR and threshold. And then now I'm creating a data frame for this, and now in data frame I'm giving FPR as FPR, TPR, TPR threshold. And now I'm creating also a G mean. What G mean is NP dot square root TPR into 1 minus FPR. G means is G means is square root of TPR into sensitivity. What sensitivity is? Sensitivity is recall of negative class and TPR means recall of positive class. So if you want to make a generalized model in which our recall for both classes must be balanced, in that case we will use G means. And now you are able to see that we want to increase our TPR, true positive rate, so that our model will be able to predict positive class correctly, all positive class correctly. So here you are able to see that our recall is 96 here, and here you are able to see 98. Here you are able to see 98 and then 1 at this threshold. For default threshold, in default the default threshold in sklearn is 0.50, somewhere like here. Okay, 0.50, where our recall is 94. But now we want to increase our recall, so we will select this value, because at this value our FPR is lower and our TPR is maximum. So FPR, you can change FPR as means false positive rate. So at this threshold model will not make so many false positive, but it will create true positive as 0.98. So that's why I'm selecting this threshold as 0.42. We can select this one also as 0.34. For now I'm selecting 0.98 just to show you how does it work. 0.42. Let me just run this UCRS curve. So I will just copy this threshold from here, 0.42. And now for adjusting threshold, I'm doing the same thing once again. So I just written this again and then I will delete this. Here I have to give the same probability, this one positive proba. Here I will give the positive proba again, and then I will copy the threshold. Suppose if we want to get the maximum recall for uh, COVID positive, then we would select this one, this one threshold. So I'm selecting this threshold as 0.34. So here I have to pass this condition, and then if this condition will satisfy, it will return 1 and otherwise 0. It means that even if we will have 0.3% chance of having someone COVID positive, then it will say as positive. Now run this. Now let's making confusion matrix on this answer. Now you will be able to see our 49 out of 50 has predicted correctly. And now classification report, you are able to see now 98%, we increased our recall as 98%, but precision again, look at this, precision got decreased. And so in this way we change our threshold according to our question. I told you changing threshold is a way when you have to create such a model where you suppose you just want to create a model which can predict some virus outbreak or something like that. Then in that case you will need to change threshold. Again you are able to see that precision is when you increase recall your precision get decrease, and when you increase precision your recall decrease. This is the same trade-off. So there is always a trade-off between precision and recall. You can set by doing the same thing by using the same graph as we did for positive class. Thanks for watching this video. If you don't understand, if you don't understand any kind of topic, any kind of line in this line of code in this section, you can just comment me on YouTube and I will try to help you. Thank you very much. Thanks for watching this video, and please do share and subscribe this channel for upcoming videos based on deep learning and machine learning. Thank you.